And hopefully everybody can see my screen and hear me okay. So with this presentation, what we want to cover is masonry. So similar to the last presentation, to be honest, but a completely different, similar but completely different, if that's possible. We're going to talk about masonry wall, horizontal reinforcement, and movement joints, but we're really going to be looking at it from a completely different perspective. Really, the presentation that we're doing today is really kind of a modification of a presentation that we do quite often, movement joints from a structural perspective. We develop a lot of these presentations with the International Masonry Institute. We do a lot of work with the International Masonry Institute and a lot of different structural coalitions across the country. So you're going to see some similarities here to this presentation, but we certainly went, like I said, expanded on some ideas and added some more information. So I'm Sam Rubenzer, as Gina just said, background in structural engineering, licensed in many different states, consultant with IMI for over a decade. And so, working with Pat Conway, and many of you guys know Pat Conway very well, if not everyone on the call. So, really Pat and I developed a lot of these presentations, and this one today kind of with some back and forth with some different ideas and concepts. And, really this presentation is going to be a lot about creating different options, creating some different perspectives on these different options that you have for structural masonry design. Because really, when we look at this, this type of a design, the examples that you kind of see up here on screen, you have these masonry walls, and we have walls with a lot of openings, and there's so many different ways that we can do this by code. There's different, areas of the country which have done a design of masonry walls with a lot of openings in certain ways. Really what I'm trying to do is just pull together a lot of these different ideas and try to give contractors, designers, different options to consider for what might be the best way to build these walls. Because I think with masonry, structural masonry design, sometimes we have different agendas of what we're trying to achieve with the design. It's just not a one size fits all. There's not just a one way to design and build with masonry. We have a lot of different options. So really this presentation is really about exploring some of those different options, planting some seeds with different ways that we can approach the design of masonry. So like I said, we have the best wall that's going to have the most structural capacity, or if we need more capacity, performs well architecturally, and a wall that's affordably built and is going to last a long time. So like I said, it's all about perspective. A contractor is going to look at cost implications versus constructibility, between different options that I might present. An architect's going to look at this thing like, well, how is this going to look? How is it going to perform? Will it crack? So I understand there's these different options. And then just the mere mention of building part of a wall or all of a wall without control joints. And engineers tend to look at me like, in Wisconsin, without control joints. And I think that there's a lot of times where we want to build masonry without control joints. So we're going to kind of explore some of those different options, and like I said, look at what might make sense in different scenarios. And then other things, when we talk about engineers not necessarily trusting it, has this been done before? That's really something that, again, we're trying to pull in different ideas from different parts of the country. It definitely has been, all the different options that I'm going to present today walls have been built this way and stood the test of time in many different load conditions. So, that's one thing that I try to answer. How do I analyze walls as I kind of pull these masonry walls together and create complex engineering problems, just because I have openings and lintels and jams and everything kind of interconnected. It really requires a high-end software program to do that. I'm not going to get too far into the weeds of software, but I will point out a couple of slides, where you can see that these things can be done with the right tools. And so again, we're trying to create options. We're trying to create some things that can work for a variety of people. So learning objectives, this one, Leroy did a really good job of talking about some of these definitions. We're not going to spend a whole lot of time on that. just other than maybe doing a little bit of comparing and contrasting between what might be in an unreinforced situation versus a reinforced situation, the different definitions and then how maybe might be different. We're going to look at some horizontal reinforcement options. And this one is, again, you go to different parts of the country and people tend to just use just one of the options predominantly. And I see that makes some sense, but I think there's different conditions where some of the different reinforcement options that you have available might work for different conditions. So again, we're gonna talk about that a lot more. But and then I really think there's a balance between these control joints and reinforcement options. There's some times where we want to stick to traditional methods, just because that's the way things have been done and everybody's used to building them that way. And then, like I said, there's times to move into these new ideas and maybe pull some ideas from a different part of the country to try to make the design a little bit better. But there's a balance, where I'm not trying to convince anybody to stop putting control joints in structural masonry walls. That's not what I'm trying to do. But I'm really trying to, like I said, create some of these different options and then try to strike a balance between these different design scenarios. And then just kind of look at the end a few case studies and look at some of the different design impacts, structural design impacts of the different options, why some of these things are important to consider. So again, this presentation, when we look at these things, we're really focused on horizontal reinforcement control joints. It's really not going to change some of the different ways that we approach the overall design of the wall for like a vertical bending or stuff like that. It does change a little bit of some of the details of the wall, lintel design and stuff like that. We'll talk about that a little bit, but what block and mortar and grout and vertical reinforcement tends not to change too much depending on the different options that we choose here for predominantly for the wall design. But we'll talk about that as we get through. So again, when I talk about this, we're talking about these different options. Probably the first question that people ask is, don't masonry walls require control joints? Don't you have to put them in walls? And that they don't require them. There's walls in different parts of the country, as I said before, that are built without any control joints, and that's something that's certainly doable. Again, there's going to be certain rules that you have to follow. As Leroy pointed out, with a veneer and unreinforced veneer, yeah, you definitely have to put joints in there. You have to put them in the right location. So when I talk about getting rid of control joints, I'm really talking about reinforced masonry walls. It could be a reinforced veneer. Again, those are pretty rare. More commonly, it's going to be the reinforced structural backup wall, or maybe it's a single withe wall reinforced masonry wall. That's the wall that we're kind of looking at. Do we need control joints? Do we not need them? If control joints are provided, then where do we put them? And how much reinforcement is needed when we have control joints? And then when we don't, put control joints in, how much reinforcement do we need in those situations? So we're really going to try to kind of explore these different things in the next hour. So just a really quick review, and again, Leroy covered this, and I'm not going to have to cover this too much in too much detail. But this is something that this is a Pat Conway slide. If I ever saw one, it really kind of looking at just the bare basics here. All buildings move. Concrete masonry shrinks, clay masonry expands. Again, we saw that in the last presentation. Pat's talked about that for many years. And really, you have two different options. You can accommodate that movement, which is really the last presentation with an unreinforced veneer and stuff like that. You really are trying to accommodate it, add the right amount of control joints, or restrain. Really, when you talk about structural masonry or reinforced clay veneers and stuff like that, we're really looking at restraining. How much restraint is really some of the different options that we're going to be looking at. So. In the different NCMA tech guides are really going to be our resources for looking at, and reading through all of them. I mean, I think NCMA is going through an effort now where we're trying to combine all these different tech guides, so you'd have to go dig for all of them individually. But it really does help us kind of see the purpose and the reasons behind the amount of horizontal reinforcement, the control joint placement, whether to put them in or to not put them in. I mean, it's very well documented in here, and it gives a lot of different historical data for, how this has worked well for masonry walls, but then it also gets in a little bit more into the engineering methods for, how we can move them around or accommodate and consider different options for control joints. So again, different options that could be possible: joint reinforcement and control joints. That first one I listed, that's the typical, Midwestern wall, right? I mean, that's what we've been doing all the time. But the second option, bond beams and no control joints or joint reinforcement, that's a really nice option. There's times when we have a wall that really, we already have plenty of bond beams in the wall. Maybe again, it's a wall with a lot of openings. Boy, if I have that, then do I need the first one? Do I need to have bond beams and joint reinforcement and control joints? Well, I don't. And so then, we can look at that. Or maybe it's a combination of joint reinforcement and bond beams and no control joints. And we have a lot of different scenarios that we can look at. But it's really, these tech guides are going to be what, I used for this presentation, really the resources for how I kind of define some of the different options that we look at here is really from all the data that's in these tech guides. So again, this is a really good thing to look at, talk about, what are these things called? Movement joints can be called control joint, can be called expansion joints. As Leroy said, I really don't care what you call them. I'm going to mainly be focused on the joints that are in a structural wall, whatever you might call it. I'm going to call everything a control joint for the rest of the day. But again, I understand that there's different verbiage out there for what these different joints are. And there's very important reasons for why they're called different things. And again, last presentation really kind of covered that well. But again, I'm focusing on the structural masonry. I'm going to focus mainly on the control joint aspects. But there's definitely different types and labels that are used. All right, so one of the other things that we talk a lot about, Pat and I have talked a lot about, is control joints and expansion joints not needing to align. We have these, in this cavity wall, we have these different elements, and there's very different things going on in both of them. Again, the veneer being an unreinforced element and really having its own set of rules for where expansion joints go. This backup wall, we're going to look at control joints. If we have them, they have their own set of rules. They're very likely going to be in very different locations, and that's certainly okay. It's almost a good thing, And so, if we look at in this presentation, if we look at eliminating control joints, again, that doesn't really change our strategy with the veneer. It's still an unreinforced masonry wall. It's still going to have, very little lack of restraint for. When we look at the building and the clay and everything moving, we are still going to have quite a few of those expansion joints for all the same reasons that we've always looked at them. And so as I'm talking about this backup wall, and I'm really looking at whether to keep control joints or not, to have them in or moving them in different locations, really doesn't change the strategy that we have out in front. So it's really important to remember that. As we talk about this is another slide that I think is really important to always remember, that it's not a contractor's responsibility to indicate these. I mean, this is an engineer's responsibility in the structural backup wall. An architect's going to locate them in the veneer. There really needs to be a lot of coordination between them, to make sure that both of them understand, what the other is doing. But ultimately, they're two different WISE, two different situations. We have to just make sure that we have the right balance between them as well. But it's the architect and engineer, a contractor, and I've helped contractors come up with different alternatives, which then have to be sent back to architects and engineers to approve. But it's definitely not the responsibility of the contractor to come up with this movement strategy. One of the things that I always like to talk about as I get into these type of presentations is, the presentation that we just had and other ones from IMI really do look at different movement joint basics, again, for veneers, something that's unreinforced. We have a lot of different reasons for why we want to have vertical joints or horizontal joints in veneers. And these are certainly very good reasons. And again, this isn't the focus of today, but really what I want to talk about is, I have some structural masonry. I have very different reasons for why I want joints. And so, vertical joints Needed to prevent cracking, yes, we want to have some vertical joints in there. Can we add enough reinforcement as I get to number 3 here? Absolutely, so that I can eliminate some of those joints. If I looked at a veneer, there's almost never a time where I would eliminate vertical joints on the veneer. So there's very different things going on here, and it's important that we remember and see that what I'm talking about in this presentation has a lot to do with structural masonry, reinforced masonry. Again, those horizontal joints that we talked about in the last presentation as well, very good reasons for why those are in there. And then there really shouldn't ever be horizontal joints in structural masonry. And again, just trying to point you guys to this contrast between the two. We have very different things going on between this unreinforced veneer and this reinforced structural masonry wall. So as I talk about, control joints and possibly eliminating them, some of the things that I've talked about before, isolating structural elements, stuff like partition walls. Partition walls are still going to need control joints in there. We're still going to have to make sure that we isolate them for the rest of the structure. So no matter what we're trying to do with the external wall and moving control joints around and stuff like that, we're not going to eliminate them in every area of the building. There's still going to be parts of the building that we're going to have to make sure that we can isolate elements like partition walls so that those can be very lightly reinforced, and those can be something that can be unreinforced elements within buildings. So again, just trying to keep the perspective right here. Like when I talk about eliminating them, I'm not talking about eliminating all of them. If I talk about shear walls, sometimes I have to specially reinforce shear walls. I might add some control joints in there. Maybe the rest of the building, I don't need them, but some of these elements, I want to make sure that I can isolate, with some control joints. So again, I might be looking at just moving joints around. Maybe I'm not looking at eliminating them altogether. All right, so really important to kind of keep some of this perspective in the back of your mind. Right, because we don't want to have this type of situation where we have joints everywhere. This has been something that was been done a little bit historically, put in a lot of joints. When we have all of these openings, it creates some very simple elements for shear wall analysis and design. And really we're trying to move away from that. And as I said, we're trying to eliminate putting joints at every opening in every wall, but maybe I still do keep some of them. Maybe I do keep them fairly regularly here. Because that's a different strategy as well. So some of the concepts that we're going to talk about today, maybe have you keep some of the joints in, but we try to eliminate them to try to gain some structural capacity. So hopefully this is helping you guys. I know this is a lot right away, but I'm just trying to set the stage for what I'm talking about when I talk about moving some of these joints around. And this is another slide to kind of point to the fact that you can't just have maybe one single strategy. It's really going to depend between the different veneers, whether or not they're control joints, expansion joints. And there's just so many times I see in a general notes just a single sentence that try to define these joints. It's just way more complicated than that. We really need to locate them on construction documents. Okay, so let's get into this a little bit more. Some of the guides that we're looking at here, when we look at control joints that are placed kind of typically within a wall, we have this NCMA tech guide, that talk about 1.5 times wall height not to exceed 25 feet, which is similar to NCMA for a veneer when we have 1.5 times wall height not to exceed 20 feet, kind of a similar recommendation there. And then there's, again, this NCMA guide that looks at horizontally reinforced walls that really allows us to have no limitations on where control joints are placed. And that's going to be NCMA 10-3. And really it looks at an engineering method. It looks at the stresses and forces that you have within a wall and tries to make sure that we have the right amount of reinforcement to prevent any of those stresses from creating cracks in our design. Typical common horizontal reinforcement options. We have joint reinforcement, obviously, that we have that gets placed in walls. Very common to have 9-gauge wire that we can use. Heavy 3/16 inch wire has been discussed, and we'll talk about that option. That certainly gives us a little bit more liberty to where to put control joints and creates other options. But that's joint reinforcement that I think is pretty hard for contractors to use, and it's typically not something that they would prefer to use. So it's certainly an option, something that we can explore, but we want to make sure that we talk to contractors before we look into getting into that type of reinforcement. So again, horizontal reinforcement, usually in Wisconsin, we're just looking at those first two options. You know, with the joint reinforcement, really bar reinforcement, rebar is something that can be used instead of joint reinforcement. We don't have to have joint reinforcement in every masonry wall. Typically, bar reinforcements can be placed in bond beams. It's very common to have bar reinforcement be the only horizontal reinforcement in mid to high seismic areas. So that's where some of the stuff, you know, we could see these projects in these buildings in these areas where we just have bar reinforcement, no joint reinforcement. And we can see, you know, what's happened in those buildings and how that's worked very well. And so again, we're stealing some of those ideas for times in a low seismic area like Wisconsin and Minnesota, Illinois, and these Midwestern areas where we don't have much seismic, but we know that this works. So maybe it's going to work for reasons of a lot of openings, or, you know, reasons of different loading conditions where, you know, we just maybe want to use some bar reinforcement. So again, that's where some of the ideas that we're going to steal from. You know, the code is kind of silent on exactly what you have to do for horizontal reinforcement, other than saying that reinforcement's not allowed to be more than half the width of the concrete, you know, that it's being placed in. So for the mortar, for example, so half of 3/8 inch common mortar joints is going to be where that 3/16 inch diameter wire comes from. So again, that's really at the limit of what you want to place in the mortar joint. Again, maybe that's why contractors don't love it, because you're kind of, whenever you press something right to the limit, it's obviously maybe going to be something that's going to be hard to work with. But that's also why bar reinforcement, you know, I've been asked that question, can you put bar reinforcement within mortar? And that's never an option, because, you know, even with a number 3 bar, that's going to be 3/8 of an inch. That's not something that can go into a mortar joint. It obviously has to go into a grouted bond beams. So a little bit about our horizontal reinforcement options. You know, how much and where, there's a couple different, like I said, guides here. We have an empirical method. You know, empirical is certainly going to give us, you know, how things have worked over time. And there's certainly some value in seeing that. I tend to be, as an engineer, a little bit more into the engineered method to have a little bit better understanding for materials and what reinforcement we should use with some of the different materials to make sure that, you know, cracks don't occur where we don't want them. So empirical is nice, empirical is good. But I think it's always good to look at things with an engineered eye as well. So with these different methods, obviously joint reinforcement is going to be closer spacing than bar reinforcement. We have a lot less steel area with joint reinforcement. Bar reinforcement is, you're going to have larger spacings, but not unlimited. I mean, you have what we're trying to do with this reinforcement is, again, control cracks from occurring, or control cracks from opening too large for any of the you know, any of the different design situations that we're looking at. Aesthetically, we don't want to see cracks. Or if you have a single width wall, you certainly don't want to have cracks that open up too wide where, you know, you'd have moisture being getting into masonry walls. So the reinforcement, you know, we definitely do want to make sure that we're careful with distributing reinforcement or putting it in places where where cracks maybe would occur. So, you know, bar reinforcement does give us, like I said, the option of having a larger spacing a little bit less often where we have to put reinforcement in walls, but we still want to be careful, and it's definitely not an unlimited situation where we can put them, you know, say every 20 feet vertically. You know, we definitely want to have them spaced out. So, you know, when I talk about spacing, code is definitely silent on this topic. So really, we do rely on the NCMA tech guides to look at what the actual horizontal reinforcement, how much and where, and actual spacing limitations and stuff like that. So that's what we'll look at here. So this empirical guide, this is something that I think is, like I said, it's something that's proven over time. We've seen this work many different areas. This is the, you know, the tables that you see from NCMA Tech Guide 10-2D, really looking at, you know, again, with an 8-inch high masonry, we have 1.5 to 1 in terms of length to height ratios. And then that's that 25-foot spacing. So, that's where we're going to come up with the 9-gauge wire at 16 inches on center, as you can see in the table in the upper right. So you can see that there are different options. If we want to use this empirical method, we don't have to just use the 9-gauge, two 9-gauge wires. We could get to the 3/16 inch wire where we could go, 24 inches, or we could start looking at, something like a number 4, number 5 bar and adding that reinforcement. So this is an empirical method. It definitely gives us, a good perspective on what we want to use. And then the second row there, you can see the 4-inch high. That's going to be that veneer type of option where we have the spacing at 20 feet, and then you have maximum horizontal spacings for the different horizontal reinforcement options. So I think, again, this is looking at having control joints in the wall and the amount of joint reinforcement that we would need with the control joints added to the walls. I think what's really interesting is when we go to the engineered method and consider keeping in control joints. Again, this is very similar in terms of control joint spacings. You can see in the table on the bottom left, we have different length that we look at there. But you can see a much more expanded table, a much more expanded table for the different types of reinforcement and different thickness of walls. If I go back here, you're really not getting a lot of different variation. This is a very simple table. It's empirical method. And this really does make me think a little bit like, boy, how do these two things compare? This is a lot of numbers and a lot of data. What are we trying to do here? And so what I tried to do is I tried to look at, again, this is a horizontal reinforcement for keeping control joints. There's ungrouted and partially grouted walls, and then there's fully grouted walls. And if you look at the numbers in here, obviously, as we have a fully grouted wall, you can see horizontal reinforcement when we keep control joints. Well, that reinforcement should be a lot closer together. The two 9-gauge wires, if you look at the table again on the right, the far right column, if I have a solid grouted wall, it's only a 6-inch solid grouted wall that I could actually even use that for horizontal reinforcement according to the engineered method, right? Because with the engineered method, what we're trying to do is look at the concrete material. And when you have a solid grouted wall, you have a continuous concrete volume that's much higher than if you have a partially grouted wall. So even a wall that's, say, grouted 16 inches on center, the continuous concrete that you would have would really just be the face shells. So that's why an ungrouted or partially grouted really can have a lot less reinforcement than a fully grouted situation. So again, as we get into designs and I see people designing with fully grouted walls for one reason or another, but then they use the empirical method, I'm thinking to myself, boy, that's a little bit dangerous. We have a lot of concrete, a grout and concrete in the masonry block that really, this is telling me I probably need more joint reinforcement than what the empirical method showed me. So again, what do I do when I'm an engineer? I create a table. I look at this thing and I say, all right, so you can see the yellow line there. That's the NCMA Tech Guide 10-2D. That's the spacing of the different reinforcing schemes that they have there. And then how does that compare to NCMA 10-3, the engineered method? So everything in the white and gray parts of the table, that's going to be stuff that's going to vary based on the thickness, based on the amount of continuous reinforcement. When you look at the top table, you can see when we look up and down, the column, this actually, the empirical method does work pretty well for when we have a partially grouted or unreinforced a wall. Our spacings that we have there maybe a little bit on the conservative side, especially for the different joint reinforcement options. And then on the bottom, what I'm trying to show everyone there is the fact that my spacings that I would have for joint reinforcement based on the engineered method, far exceed what's in NCMA 10-2D. It really shows when I have a fully grouted wall, those spacings of joint reinforcement, whether the bar or two number 9 wires, that's just not sufficient for the amount of horizontal reinforcement that you need. So, I get asked the question from time to time. We're looking at maybe eliminating control joints or moving them around, and I often point back to this and say, well, if you have a fully grouted wall, you have a lot different requirements for horizontal reinforcement than when you have a partially grouted or unreinforced and ungrouted wall. Okay, so moving on from that, when we look at other horizontal reinforcement options still within the engineered method, what the engineered method has us looking at is, the last couple of slides, we're really looking at how much reinforcement do we need when we have those control joints in the wall, at 20, 25 feet. That requires a certain level of horizontal reinforcement. This method, there's also an option to eliminate those control joints altogether, because control joints are really being added to the wall to allow some stress to build up, but then relieve it every so often within the wall. So if you're thinking about, these shrinkage in temperature or all the different stresses that we have that could be accumulating within the masonry, if I'm relieving them every 25 feet, I have a lot less reinforcement. If I want to completely restrain any of those stresses from actually developing and opening up, cracks that are too large, there is amount of reinforcement that I can add. It's about 3 times the amount of reinforcement that I would add if I wanted to keep control joints. So hopefully that makes sense. We can add enough reinforcement to actually prevent cracks from occurring, and we can not have to worry about having control joints to relieve stresses because we have sufficient amount of horizontal reinforcement in the wall to prevent any of those cracks from opening up too much. And so this is later in the NCMA Tech Guide 10-3, the engineered method. This is getting into the how to eliminate control joints. Really what this table looks at is looking at just bond beam reinforcement. You can see here it changes for thickness, and you can see just as with the last slides, fully grouted walls do require a lot closer spacing of the reinforcement to eliminate control joints. So again, here you can see the actual area of steel that's required is the 0.002. Previous methods was 0.0007, so about 1/3 of the actual area of steel that was required. So again, as an engineer, I'm going to be checking all of this out, and I create a table, and I kind of expanded this a little bit, because that table that, they provided within the guide, it gave us 3 different options, a number 6 bar, 48 inches on center, number 5, a little bit closer, number 4, bar as well. I think that there are times where you maybe can look at, joint reinforcement could work for thinner walls for eliminating control joints. And so I just kind of expanded that table. That's really what this slide is looking at, expanding the table, looking at different options where we have maybe 2 number 6 bars in our bond beams, 2 number 5s, 2 number 4s. I'm really just trying to expand the table that's provided in the tech guide. One of the things that the tech guide also does suggest is a maximum spacing of 48 inches. So although by adding enough reinforcement, maybe could go beyond that, we have to be careful, again, to make sure that we have some even distribution of reinforcement in these walls without control joints. Okay, and so then, like I said, this is only rebar. There's other times where maybe I have joint reinforcement that I have in a wall, and then I want to add some bond beams as well. Can I do it with both? Can I add the right amount of horizontal reinforcement by using both of these horizontal reinforcement options? And the answer is yes. So what I'm doing here with this table is showing if I have in the wall, 2 9-gauge wires at 16 inches on center, then how much additional bond beam reinforcement do we need to add throughout the wall? So again, creating different options, giving contractors the ability to look at, how we can build these walls differently. So that's a lot of numbers for all the engineers out there. I'm sure that they loved and appreciated it. Everybody else, their eyes are kind of red and getting a little bit frustrated and sick of looking at numbers. So we're going to talk a little bit more about what some of the different options that get created from these. right? Because we've looked at these couple different strategies where we have minimum reinforcement and control joints, or the second option where we have all the horizontal reinforcement that we need so we can eliminate control joints. Right, so it really does create these different options and options. It really is, option A is going to be control joints 25 feet on center, 2 9-gauge wires at 16 inches on center. That's one way we can build a wall, pretty traditional way. Option B, we're going to be looking at a control joint 25 feet in center, no joint reinforcement, but one horizontal bond beam, one number 5 at 12 feet. Another option, we don't have to have joint reinforcement. We can just put the bond beam in at 12 feet, but keep the control joints in. Or do we go to C, where we have no control joints, but we use heavy joint reinforcement? We maximize the wire, the 2 3/16-inch wires at 8 inches on center, no control joints. Very interesting option. D, we get into no control joints, no joint reinforcement, but just a couple bond beams. And then E, where we have smaller reinforcement but more regular bond beams in a wall. So really there's different options, and you look at these different options. And we actually did this, created a survey for contractors. What would they prefer? With the different options, that because they're all equal. We have all of these that are available to any masonry walls throughout the country. If they're all equal, which would be preferred design wise? And what do these look like? Again, this is a pretty traditional looking Midwestern wall. We have these control joints pretty regularly, joint reinforcement. And so there's a lot of contractors that would prefer to just keep doing this. And there's a good reason why, this has been preferred here in the Midwest. We don't need a lot of other horizontal reinforcement. We have very low seismic, so this is probably and was preferred by most contractors for common walls, for walls that, look like this. This is an option that's very similar. We keep the control joints, but we add the bond beams. There's some contractors that really don't love joint reinforcement. Some of them have been getting just different situations where they would prefer to just have bond beams. And so that this gives them that option. They can look at, well, for whatever reason, if joint reinforcement, maybe it's a long lead time, maybe it's whatever it is, they're concerned about quality and stuff like that. And again, right, wrong, or otherwise, contractors having an option to keep the control joints, but look at just a bond beam instead of joint reinforcement. I think it's a good option to have for different scenarios in design. Option C, this is again one that we're just kind of exploring, what would work. We take the control joints out of this wall, and then we add the amount of horizontal joint reinforcement that we would need to prevent any of those cracks from occurring. And that's really that 3/16-inch wire every 8 inches on center. I think this is the only option that every contractor said, no way. We don't love the 3/16-inch wire. Control joints aren't that bad. We don't want to be putting in wire every course. And, so this is an option that kind of got discarded right away, but certainly that's something that was available. Option D, where we have a couple bond beams and no control joints, this starts to get a little bit more interesting, depending on the wall, depending on the design of the situation. This could be something that contractors are really starting to gravitate towards for certain different types of design scenarios. And then option E, this is similar. It's less reinforcement in each bond beam and then more regular bond beams. So that obviously there's going to be more even reinforcement for the stress that could be occurring within walls. So 5 different options, that contractors looked at. We also did have a couple little, interesting little exceptions here. What happens when you had openings and regular openings? Actually, when you start to add some of these openings, putting in those control joints, all of a sudden, maybe you have to add in more control joints. And we have these lintels that masonry lintels always now, right? But we start to have some of these elements. Does this change things? Option A, this is actually a pretty expensive and low capacity from a structural perspective wall. What we find out is, when we have those repetitive openings, eliminating those control joints, having some of this reinforcement go continuous, this is something that is pretty natural. It's pretty easy to build. We already have bond beams that are there for the lintels and sills that we're developing because of the openings that are in here. Just taking that and going continuous with the wall, it's a pretty easy fit. So this is the kind of the scenario that, even in the Midwest where we're used to putting in control joints, this is kind of coming up as, boy, if we have enough openings and they're fairly regular, this can be a really nice design option for contractors to look at. Get rid of those control joints. From an engineer's perspective, boy, that gives me a ton more capacity for this wall. My wall can do a lot more now when I take some of those control joints out. So contractors are happy, engineers are happy, architects are happy, everybody's getting along, I think. So it's a win-win-win all the way around. So again, I would say for the most typical walls, when we don't have openings, the first two options that we have here in the Midwest, we don't have to put in bond beams. Those are certainly preferred options for contractors for the typical plain, no opening masonry wall. But it's this option D, this one that's really kind of coming up and becoming a lot more popular as we have openings and pretty regular openings within our designs. It's something that we can look at and explore. Maybe with the regular openings, maybe it does make sense to just take some of the lintel reinforcement, sill reinforcement, make it continuous. And then, once we do that, then we can look at different placements for control joints and joint reinforcement. And maybe that doesn't make sense for some of the walls. So let me just give you a few different examples. This is an example that we've been using for a lot of years, and really these repetitive openings. This is just a bunch of different dock doors. There could be fire stations. Are examples that we use. Anytime that we have many different openings on top of each other, it's hard to put control joints in these walls and actually have the wall perform well structurally. Hard to put control joints in there architecturally. It's hard to put control joints in there for a variety of reasons. So, there's just very minimal place to put them. If we try to force them in here, it does create a lot of different problems design-wise. We have contractors that end up having to put them in because the designer didn't really think this all the way through. Like I said, there's very minimal locations that we want to put them. And then when we do put them in, it does create the situation where, well, now the lintels have to work that much harder. Now the wall doesn't work as a shear wall. Now we have, in this case, we have steel that we have to contend with, and that really minimizes the jams that we have in there. So there's just all these different complications, and there's too much isolation. This wall, has many different issues that really could have been resolved if we would have eliminated those control joints. Now, the nice thing about this, as I always point out, is we have all of the horizontal reinforcement already there. We just need to make it continuous. And then all of a sudden, this wall that here is very complicated and frankly doesn't have much capacity, suddenly gets very simple, has a lot more capacity, and just there's a lot of benefits for every different contractor, architect, and engineer that's involved in these designs. From a movement perspective, again, for any of the structural engineers, it's just once we connect everything, it's going to be a lot more robust. And as I always point out with this, this type of design, we can have control joints in the regular walls in this building, and then we cannot have them, in this area of the building. This is something that's becoming more common, and we have more contractors kind of gravitating towards this. So you could have two different strategies used on the same building, and that certainly works very well. This is another example. This is just one wall of a gymnasium. This is repetitive big openings. Again, people like light coming into their buildings. They don't like to live like engineers in basements. The light is good for people. And so we have these big openings that get added to, structures and schools and gymnasiums. Maybe the rest of the gym all has the typical common 25-foot strategy used, and then you have this one wall. Maybe we don't have any control joints. We just take all of that reinforcement, make it continuous, and that works very nice for this design. Sometimes we have a huge long opening, and this is a wall that was actually built here in Wisconsin in the last year. And so this is really what the detail looked like. And I look at this and I'm like, well, one, now the control joints are spaced probably a little bit further than they should be. When I put them in that location, my lintel actually has to work that much harder, because those control joints are there. Again, the opening is so wide that I really have to put them at the end of the lintel because I'm beyond the 25 feet with this large opening. But if we would have considered just a different option of eliminating those control joints, really only requires us to take some of that lintel reinforcement and make it continuous. And now we've eliminated the control joints, which I think is a better, much better from the structural perspective. It's going to be more cost effective, because we're going to be able to use less reinforcement, say in that lintel. And this really just all the way around becomes a very good and much better solution. So here we kept, some of the joint reinforcement in there, and so allowed the, just some of the lintel reinforcement to be continuous. So again, just different options that contractors are considering. This is another one of those designs where we have a lot of lintels, a lot of horizontal reinforcement that's already there. Do we really even need control joints in there because of all of the horizontal reinforcement? Can we just make some of it continuous? And boy, that was a really good option for the contractor for this design. Same building, a little bit different part of the building. Again, a lot of repetitive openings. We already have the reinforcement in there for the lintels. Can we just make it continuous? That made a lot of sense. If you look pretty closely here, you can see there's an area in the center though that had to be solid grouted, and that area was actually supported a little bit different. So, in this building, we eliminated control joints, eliminated horizontal joint reinforcement for some areas. In that center area that's a little bit darker gray, you can see control joints on each side because we have differential support, right? So we eliminated control joints in some of the walls, but other areas we had to keep them because those walls would be supported a little bit differently. So again, creating different options and using different strategies here within the same building. Wall groups are ones that we talk about and have talked about. Again, just other times where we don't want to add control joints in these wall groups. They have so much more capacity if we don't add in some of those control joints. Just looking at the capacity, if we add control joints in, at these openings, we really do limit the capacity of the groups, where only certain walls can handle the loads in certain directions. And again, keeping horizontal reinforcement, keeping this box gives the overall structural capacity a huge advantage. And can resist a lot more load, oftentimes being able to resist a lot of the lateral load that a building would see by just keeping this to be a boxed wall group. So again, these do get kind of complicated. This is just some software showing a full model, showing all the different elements of the walls. And, we really do need to have some of these different software tools available when we start to look at eliminating control joints or moving them around within a building, different strategies for different areas. So having the right tools certainly gives engineers the ability to do that. So in wrapping up, again, what I tried to present to you guys today, and again, some of it was a little bit heavy in the engineering side, but I really wanted you guys to see different options for horizontally reinforcing masonry, and then which gives you different options for movement joints and where they have to be, different options for moving them around. So you really want to have some different reinforcement and movement strategies. You can use different strategies within the same building. One area you could eliminate control joints, the other areas you could have them very regular in the design. And then, all of this stuff definitely does change the structural capacity. So there's going to be times where we can really increase design capacity by eliminating some control joints, or we increase the lintel capacity by moving some of those joints around and away from lintels. So hopefully you can see some of the different options there. And again, it was a lot of information kind of coming at you. Certainly you can come and talk to anybody from International Masonry Institute. Again, here in Wisconsin, Pat's a great resource, reaching out to him to discuss some of these things on your project. And then some of the different resources that we had and that I used for the presentation, obviously the TMS BIA guides, but then all the different NCMA tech guides, really the different information that I used to create the presentation. So that's all I had for right now. We could open it up to questions if there's any questions, or if there's no questions, I have some commonly asked questions that we can go through if everybody's clear as mud, or I sent you so much information it was just too confusing. So either way.
Sam, this is Gina. I don't see
Hi,
any
Gina.
questions in the chat. So if anybody does have any questions, if they want to ask and or put in the chat. Otherwise, if you want to address a couple of those common
Perfect. Perfect.
come across, that would be great, Sam.
All right, awesome, excellent. Okay, so again, horizontal reinforcing. One of the questions that I get asked after doing a presentation like that is, I'm suggesting using bond beam reinforcement on those options. Do you still need to put in joint reinforcement? And that, right? No, you don't have to do that. Either solution is sufficient. You can either use joint reinforcement or rebar reinforcement for the horizontal reinforcing strategy. You definitely don't need to keep both in your design. So anytime that we talk about, say, the fire station with the lintel reinforcement, that's just rebar. That's all you need. You don't need to add horizontal joint reinforcement. I mean, you can keep it, right? There's nothing to say that you can't, but you don't have to keep the joint reinforcement in that scenario. And this is another question. When I'm talking about eliminating control joints, if I use the NCMA Tech Guide 10.3, the engineered method, can we really not put any control joints in buildings? And the answer is yes and no. I mean, you have enough reinforcement in it to control cracking, but there's still other reasons to add control joints. One of the buildings that I showed you guys, we had different support conditions. We had some masonry walls that were sitting on plank, and we had some masonry walls that were sitting on a wall below. There's just different support conditions are still going to require a joint in between them, even if we have enough reinforcement. Sometimes changing height of wall would be a good place to put a control joint still. Locations of overall building expansion joints, obviously we don't want to not have a joint in the masonry wall. So there's still plenty of times for putting in control joints in masonry walls, even when we have sufficient amount of reinforcement in there to prevent cracking. All right, so this last one's kind of a three-part answer. And this is something that, there's a few IMI colleagues and I were having a little bit of a discussion. So we'll get into this question. Really kind of what I identified is, a strategy for going with horizontal reinforcement and control joints at 25 feet. And then I'm saying another strategy is to add enough reinforcement and you don't need them at all. So you could have an infinite spacing between control joints. So, why is that? Why can you, do that and with, a certain amount of horizontal reinforcement, 25 feet, and then because it's really looking at, designers are using a reduced level of reinforcement and controls cracking, but then we have to relieve them every so often. So that's, again, that empirical methods kind of showed us 25 feet, a pretty sufficient place to put them. Again, so that first part of the answer is it's kind of historically known that 25 feet is worked as long as we have a minimal amount of reinforcement, right? And so the second part is that 0.002 ratio of reinforcement to concrete. What that's really looking at is providing an amount of reinforcement that allows you to mitigate any stresses that are going to occur within the concrete. So as soon as the concrete, we look at the level at which it would crack, and then we provide the reinforcement in there so that the reinforcement doesn't yield, and then the cracks can't open up. So it's really kind of that balancing of materials, really looking at keeping those cracks under control no matter where they want to develop within the concrete masonry. The third part of this answer is really what I think people are trying to get to. Isn't there any place in between? You go from 25 feet and then you say you don't need anything, you go up to infinity. Couldn't you say that if I doubled the amount of reinforcement, so 2 times the 0.007, couldn't I get to 50-foot control joint spacing? So my answer or my comment to that is I think it's logical. I think that you can increase the amount of reinforcement and you can get a further spacing. There's not a lot of historical data. There's not a lot of ways that we've looked at that. So it would be kind of venturing into an area that not a lot. There's not a lot of buildings that were built that way. So that would be my answer. I mean, there's good reasons for 25 feet and the lower level of reinforcement. There's really good reasons for why you can eliminate the control joints. for the most part because of shrinkage and cracking. But then those in-betweens, there's just not a lot of good data or research to support kind of that in-between approach. So, all right, so that's my commonly asked questions. I don't know, Gina, if you've had any other questions that have popped in while I'm rattling
Actually,
off some of those common questions.
Yeah, one just came in. Is there a way to compare the material cost and installation of more bond beams versus less steel and more masons building control joints? I'm thinking about the cost of masons installing with a level versus laying to a line. Is there a sweet spot?
Yeah, that's a really, really good question. The different projects that we've looked at is what I've tried to do is, obviously a designer is going to come up with one strategy, and, a contractor that's, heard us talk about having options, maybe wants to get rid of joint reinforcement. So really, it's reaching out to Pat and myself, and we come up with a different strategy for, what they might be looking at. What does the wall look like if we eliminate, the joint reinforcement, and then they can price that differently. There's really not a really good, cost comparison between, bond beams and joint reinforcement, no control joints and control joints. It's really looking at the different scenarios and trying to think about, what might be the best for that design. So again, sorry, that's not a really definitive answer. But we'd be glad to help you guys. We want to create some of these different better cost options, but it's going to be on a case-by-case basis.
All right, I guess I could bolt on to that just a little bit, testament on my own personal experience with you, Sam and Pat, the ability to come in and actually value engineer. You guys really put the value and keep it instilled in there, and do come up with multiple ways. So there might be a couple of sweet spots out there if I was to add to it. With that being said, if there's no other questions, Sam, thank you again for everything. Everybody on the call today, thank you for being a part of today's symposium. We truly